Hello dear students, welcome to the lecture series of continuity of functions, and this is our lecture number 5, and let's get into the video. We start with a problem. Discuss the continuity of function fx is equal to, this is the function given, and we are to discuss the continuity of this function. No point is given at which point you are to discuss the continuity, just you are to find this function where at which points this function is discontinuous and at which points this function is continuous, all total. So these types of problem we have already done in the earlier videos. Now let's solve this question, and it is an easy question actually and slightly differ from the previous problems here. So I am going to discuss for this question. You see, first line is same. Here the possible points of discontinuity are x is equal to -3, 0 and 2. These are the points. Equal points mean at those points where the function changes its format from one to another. That means the point -3 and then the point less than 0, greater than 0 different. So that point is 0, and then less than 2, greater than 2, that point is another point, possible point of discontinuity. At other points mean except these 3 points -3, 0 and 2. Except these 3 points, you see the function fx is either polynomial function or constant function, because you see whenever x is in between -3 up to 0, fx is 2x plus 6, and this is a polynomial function, you already know this. And from 0 up to 2, fx is equal to 6, and that is a constant function, and also it is a continuous function. And similarly, when x has the values greater than 2, then fx is equal to 2x minus 6, that is again a polynomial, mean it is a continuous function. Mean between -3 and 0, fx is polynomial, it is continuous. From 0 to 2, fx is equal to 6 is a constant, so it is continuous. And for the values x greater than 2, fx is equal to 2x minus 6, so the function is again polynomial for x greater than 2. Therefore at those points the function fx is again a continuous function. So the left out points are only -3, 0 and 2, and all other points the function is obviously continuous. So I am taking a short writing here. You see, at all other points the function is either polynomial or constant functions. So at all those points the function is obviously continuous. So you may also write in different formats by writing in the interval -3, 0, fx is equal to 2x plus 6, so it is continuous. Then from 2 up to 6, fx equal to 6, it is equal to 6, constant function, so it is continuous. And for x greater than 2, fx is equal to 2x minus 6 is again a polynomial, therefore it is continuous for all x greater than 2. So you may write in that way also, but here I am writing in a different way, so you may also prefer this writing process. And the rest of the part of the problem is similar to the previous questions we have already solved. Then we check the continuity for x is equal to -3. You see -3. So here -3 is an important point. You see x is greater than -3 is given in the definition of function x greater than -3, but x less than -3 is not given here. Mean for the right hand limit and for the left hand limit, both are not given in the question. Only the right hand limit given in the question, left hand limit cannot be obtained for the function fx here, because the function is not defined for x less than -3. So we only check the right hand limit for this function, mean right hand limit at x is equal to -3 and f3, equal line is here. So right hand limit and function value will be checked at this line, and obviously they will be equal. So you have to write that one. Okay, you see at x is equal to -3, fx is equal to, you see that one, this is fx, so you can write the right hand limit. So we are finding right hand limit here. Right hand limit x tends to minus 3 plus. Function is fx, function is 2x plus 6, then making h, so h tends to 0, 2 is remaining same here, then x is replaced by minus 3 plus h, this one, and plus 6 is remaining same. Using h 0, so this is 0, it will be minus 6 plus 6 will be equal to 0 again. So we get the right hand limit of the function is 0, and equal x equal to 3 minus 3 is also in this line, so obviously it will be 0. So f minus 3 is equal to 2 into minus 3 plus 6, this one, and so that is also equal to 0. And this is obvious. You may also write the function is continuous from right. This function right hand limit and function value at the point minus 3 are equal, therefore the function is continuous from the right side. No left hand limit to be discussed here because the function is not defined for x less than minus 3. So you just write that line. Therefore the right hand limit, this one, is equal to minus 3, f minus 3, and therefore the function is continuous from the right side of minus 3. So therefore fx is continuous from right at x is equal to minus 3. One of the steps is done. Then you start with the point x is equal to 0. So go to the next slide. This is our function. You should not write this in your copy because already this is written in the beginning section of the solution. So for the point x is equal to 2, x is equal to 0, already minus 2 is checked. So x is equal to 0, this time less than 0, greater than 0 and equal 0 all are present here. Therefore we are to check the left hand limit, right hand limit and function value. So left hand limit is 0 minus fx, 0 minus is less than 0, so fx is this one, you write this, and h tends to 0, 2 into x is replaced by 0 minus h, I am writing here 0 minus h, then plus 6 is already there, plus 6, and using h 0, so it is only 6. So left hand limit is equal to 6 at the point x is equal to 0. Then find the right hand limit. Right hand limit x tends to 0 plus now, 0 plus fx, and 0 plus is greater than 0, you know that one, this is greater than 0, so fx is only 6, so it is a constant function, so limiting value is also is equal to 6. So left limit 6, right limit is also 6, and we check the function value f0. f0 is in this line, you see x equal 0 is also present in the first line, so f0, this x is replaced by 0, so 2 into 0 plus 6, it is again 6. So all these three values are equal, therefore the function is continuous at the point x is equal to 0. So we write that line. So left hand limit equal to right hand limit is equal to function value at 0. So therefore fx is continuous at x is equal to 0. Second part is done. Then you go to the point 2, less than 2, greater than 2 and equal to 3 are present. Therefore left hand limit, right hand limit and function value, all three should be obtained here. So for the point at the point x is equal to 2, we write that at x is equal to 2, again with the similar process, left hand limit x tends to 2 minus fx, 2 minus mean less than 2, so here you see x is less than 2 and fx is 6, so we write here and constant, so limiting value will be 6 itself. Then right hand limit x tends to 2 plus fx, 2 plus mean greater than 0, so this is greater than 0, fx is equal to 2x minus 6, I am writing here 2x minus 6, then making it is h tends to 0, so h tends to 0, 2 is remaining same, x is replaced by 2 plus h, you know that method, 2 plus h, and minus 6 is obviously there, h is 0, so 4 minus 6 is equal to minus 2. So left hand limit is 6 and right hand limit is minus 2, different, mean the function is obviously discontinuous at the point x is equal to 2. So f2 is equal to f2 is in this line, you see, so using that 2 into 2 minus 6, it is 2 into 2 minus 6 is equal to minus 2. I am writing this f2 for a different case, because this right hand limit, this one is the right hand limit and this is the function value, they are equal, you see, though the function is discontinuous because left hand limit and the right hand limits are unequal, so obviously function is discontinuous at x is equal to 2. But you see at the point 2 the function value and the right hand limits are equal. So the function is discontinuous, that point. Function is, I am writing here, you see here, you see, say this is the point set 2. From left side, right side the function is continuous, it is given, right side function continuous, but left side is discontinuous. Okay, left side is discontinuous. So we write that line here. Do not write this line. Do not write this function because already you have written. Then you write that line. Therefore, left hand limit not equal to right hand limit. Obviously, the function is discontinuous. I already told you. So the function is discontinuous at x is equal to 2. It is okay. But you see, but since x right hand limit and f2 these are equal, already in the previous screen you obtained this line that the right hand limit is equal to the function value. So the function is continuous from the right. At the point 2, right side will be touching the point 2, but left side will not touch the point 2. You see there. So fx is continuous from right and discontinuous from left at the point 2. X is equal to 2. So it will be more clear if you see the graph of the function. You see the graph. You see the graph. This is your graph, and it was the function. Fx is equal to 2x plus 6. This, and you see fx equal to 2x plus 6 for which values of x? It is for -3 up to 0. -3 up to 0. So you see here is the point -3 and this is the point 0. So in between -3 up to 0, equal sign is present there. So it is fx equal to 2x plus 6 it is a linear polynomial. Linear polynomial meaning is power of x is 1 only. So will be straight line. You know that linear polynomial mean the graph will be always straight line. So from -3 up to 0, from -3 up to 0, this is the graph straight line. This is the graph straight line, because at the point -3 it is 0 using this value, and at the point 0 fx is 6. So 0, this is 6, then -3 0, -3 0 0 6, joining the 2 points we get the graph of the function of 2x plus 6. Then proceed. 0 point is the point of separation, and up to 0 it is 6. Then crossing the point 0, as we cross the point 0 this way, from 0 up to 2, it is always 6. You see at the point 0 it is 6, and at the just right of 0 it is also 6, mean here is continuous. And already we have seen in the theoretical part that the function is continuous at 0. So 0 is 6, and slightly greater than 0 is also 6, slightly less than 0 is also 6, mean at the point 0 the function is continuous. So here no gap is there. And as we proceed on the x-axis, those values which are greater than 0 up to just before 2, you see, just before 2 here, not 2, just before 2, in all cases fx should be taken as 6. So 0.1 is 6, 0.2 is 6, 0.3, 0.4, etc. Then 1 is also 6, 1.1 is 6, and so on, so on. 1.9 is also 6, 1.99 is also 6, 1.999 is also 6, and so on until we give it is 2. Just before 2, always the function is 6, and this is a constant function, so it is a line parallel to the x-axis like this. But as we give the value of x is 2, then we should not use this line. Consequently, we come to the last line, this one, equal to 2, mean 4 minus 6 is minus 2 is this point, 2 this. So before all points of 2, function is always equal to 6, but as we give the value of 2, it is equal to minus 2. And for all those values which are greater than 2, the function is equal to 2x minus 6. It is a linear polynomial again, and at x is equal to 2, it is minus 2, and if you give those values which are greater than 2, say we are giving 3, say 3, then 6 minus 6 is 0, you see here 0, so 2 is minus 2, 3 is 0, so connecting this point for all values which are greater than 2, so 4 will be here, 4, 8 minus 6, this is 8 minus 6 is 2, that means this point, this is the point 2, you see this point, and so on, and it will again be a straight line because it is a linear polynomial, so connecting those points you get an infinite line, arrow line. This will go to the infinity as x is greater than 2, mean there are infinite number of points which are greater than 2. So this is the graph of the function, and I think it is clear for you. And you see the next screen. This is a question, discuss the continuity of this function, and it is a very simple question, you see, and I think you can solve this problem by using the methods we already discussed. So this is homework for you. And similarly, another question I am taking here, number 16. This is your homework, and number 16, you see, this is question number 16. Check the continuity of the function, this one, x is greater than 1 here, at the point x is equal to 0 and x is equal to 1. Also draw the rough sketch of the function. So graph is necessary in this question, and for this question graph is not asking here, so it is not compulsory to draw the graph. And I think you can solve these two problems, 15 and 16, and both these two problems are homeworks for you. You just consider, you just attention here, give attention. Fx is equal to 2 minus x, x greater than 1 here, this is just behind the video here, behind my picture, and also draw the rough sketch of the function will be there. Okay, so these two questions are homework for you. Okay, so next one, discuss the continuity of the function fx is equal to this one, and already we solved a question, and that was without this modulus sign, and everything was similar. It was sine, I think it was sine. We have done that question. X sine 1 by x was the problem, I think. So x not equal to 0 and 0, x is equal to 0, at x is equal to 0. So you are to check the continuity of this function at x is equal to 0. So process is same with the previous problem we have already done, I think in the class number 1 or 2, I think. So not 1, it may be 2, class number 2, that is L2. So you may check that question also, and the process is same, just slightly differ from that problem. It is mod x and that was not mod x, that was only simple x. So here you just take left hand limit, right hand limit, and function value. Left hand limit is in the first line, you see here, at x is equal to 0, left hand limit 0 minus fx is this is unequal 0, less than 0 mean this line, greater than 0 is also this line, because not 0 mean less 0 and greater than both are present at the same line. So 0 minus function is this one, making h this one, then using the limit, you see this one, using the limit, this is 0, limit of h is 0 into whatever be this 1 by h is a very big number, but cos of something is a number in between minus 1 and 1, because range of cos function is minus 1 1, you know that one. So this h is 0 into total, this value will be an oscillating value, that is it will oscillate between minus 1 and 1. We do not sure what will be the value of cos of 1 by h. We have not a fixed value this one, but it is a finite value between the in the interval minus 1 1. It is a finite value, but I am not sure what will be the value. But 0 into a finite number, whatever be the number in between minus 1 and 1, 0 into that that type of finite number is there, so it will give us 0. So left hand limit is 0. In the similar manner you find right hand limit, this is the right hand limit, is also is equal to 0, and f0 it is given equal to 0. So you write f0 is equal to 0. So all the three values are equal. 0, this is 0, and this is also 0. Mean the function is a continuous function. So you write, therefore left hand limit is equal right hand limit equal function value. Hence the function is a continuous function at x is equal to 0. So I think this question is understood. And then the next question, this is one of the extra question is, I am not given question number here. So this is extra question. And in the question, if fx is equal to, this is a question, this is the function, is continuous at x is equal to 2, mean function continuous, it is given in the question, then find the value of k. Just we have to determine the value of k. So function given continuous mean the limit value and the function value are equal, and the limit value is obtained from this not equal line, and function value is obtained from this equal line. Okay, so you go to the solution. Since the function is continuous at x is equal to 2, therefore just take the limit value and function value are equal. Therefore limit x tends to 2, fx is equal to f2. Limit x tends to 2, fx is this line, this one, and f2 mean x equal to 2, mean replacing x by this 2, so f2 equal to k. So I am writing k here. Okay, so now what is the target of what is the destination of this question, of this limit? Actually, in our first year class we have discussed one formula. You see the formula I am taking here. We have a formula, you see this, limit x tends to 0, then the formula was a power x minus 1 divided by x, and I think you can recall the value of this limit was is equal to what? It was log of, tell me, it was log of a, actually with base e, but it is not compulsory to write e. So log of a, and we have to use this value, this limit for the question. This limit is to be used here. But here you see, to use this limit, we have not in the exact format of the formula. This question is not in exact format of the question. So our first priority is to make this 16 as 1, because we need 1 here. So we divide the numerator and the denominator by 16, so that this number makes 1, this. So you see, divide mean I am taking common 16 actually. So 16, 16. So here will be 16, it will be 1, 4 to the power x by 16, this is 1. So 16 and 16 numerator denominator cancel, and the right hand side is k only. Okay, so then you write this line. So limit 2 to the power, this numerator is, observe the numerator, 16 is actually 2 power 4. So 2 to the power x plus 2 divided by 2 power 4. So adjusting the indices, it is 2 to the power x plus 2 minus 4 will give us 2 to the power x minus 2, and minus 1 is remaining here, and this 16 is already gone, and here 4 to the power x, and this 16 can be written as 4 square. So adjusting 4 to the power x divided by 4 square mean 4 to the power x minus 2. Okay, so minus 1 will remain same. On the right side it is k, so mark it by 1. Now our formula is a to the power x, and this x should be tending to 0, but here you see limit is tending to 2, but it is not x, it is something different, x minus 2. So we are to take this x minus 2 as one substitution. Say this is equal to, say, y. You take that. So you see this line. This line is equation number 1, carry over from the previous screen, and you take this x minus 2, I am taking here y, and whenever x is tending to 2, then obviously here using 2 here, y will tend to 0. So you make this limit, y tends to 0, this is y, you write that. So 1 implies limit y tends to 0 now, so 2 to the power y minus 1, then this is 4 to the power y minus 1, right hand side is already k. Then to get that formula of limit, I have given in the just previous screen that 2 to the power y minus 1 divided by y is needed there, and similarly 4 to the power y minus 1 divided by y is needed there. So we divide the numerator and the denominator by y. So now limit of this numerator, is it not is equal to log 2? It is equal to log 2, and limit of the denominator, it is log 4 by using the formula just discussed. So we write that line. So 8 is log of 2, this is log of 4 and equal to k. Log 4 is nothing but 2 square. So 2 will come in front of this log. So 2 log 2, this log 2 is cancelled here. So k will be equal to half. So very simple, k is equal to half. So this is the solution of the problem. And we also finished this video here, and in the upcoming videos we have some more important questions of continuity of functions, and I think 2 more videos will be there, and then we will finish the chapter continuity of function. After then we will begin a new chapter. Okay, so thank you very much for today.